Hi everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Okay, so welcome to my video. So basically this is the continuation of lecture video for the chapter 1, which is basic concept of electric circuit. Okay, so basically this is a part 2 video. Okay, alright, so the topics that we are going to cover in this video includes current and voltage and also energy and power. Right, so let's go to the first subchapter, which is current and voltage. Okay, so electric current. So how does the electric current is being created? Okay, so what causes the electric current to flow? Okay, so basically when you have a conducting wire that you connect to the battery, okay, so you know that inside the wire you have several atoms inside the wire, and then also atoms include of proton, electron and neutron, right? Okay, so the wire consists of charges. Okay, so when you connect your wire into the battery, so what happened? Okay, so the charges are compelled to move, which is positive charge we move in one direction, while negative charge we move in the opposite direction. Okay, so this motion is actually create the electric current. Okay, so example, this figure represent the connection between the wire to the battery. Okay, so this is your wire. You connect the wire to the battery. So what will happen? The charge will start to move. Okay, so you know that negative charge move from negative side to the positive side. Okay, so proton, which is the positive charge, will move from the positive to the negative side. Okay, so in this case, it is conventional to say that the current flow will take as same movement as the positive charge. Okay, so it is opposite to the flow of the negative charges. Okay. Alright, so this is how you create the current. This is how the electrical current is created based on the movement of the charges. Alright, okay. And then the electric current, the definition of the electric current is the rate of the flow of electric charge past a point or region. Okay, so meaning that I is equal to dq over dt. Okay, so 1 ampere current, we represent it as a I and then we measure in ampere. So 1 ampere is actually equal to a flow of 1 coulomb per second. Okay, so that's why I is equal to Q over T. Okay, so it considered as a rate of flow of the electric charge in 1 second. Okay, alright, the mathematical relationship between current, charge and time is represented by I is equal to dq over dt, because I is represent the rate of flow of the charge over a time. Okay, when current is measured in ampere, so 1 ampere is equal to 1 coulomb over second. So the charge transfer between time t naught to the t is obtained by integrating both sides of this equation. Okay, so when let's say you want to know how many charge is transferred between 1 second until 3 second maybe, so you need to integrate this equation. Okay, so q is equal to integrate I dt from t naught until t. Okay, for example, you have it is equal to 3t squared minus t ampere, and then the question asks you to calculate charge from t equal to 1 until t equal to 2 seconds. So how to do that? You need to integrate it in order to get the value of q. Okay, so q is equal to integrate I dt t naught until t. Okay, so I is equal to 3t squared minus t, and then t naught is equal to 1 and t is equal to 2, right? And then after that we do the integration. So from here we integrate, we get t to the power of 3 minus t squared over 2. Okay, and then the value we need to substitute from 1 until 2, and then after that we substitute the value of t is equal to 2. You have 2 to the power of 3 minus here you substitute with 2, you got 2 squared minus 2 minus, and then here you substitute with 1, so you get 1 to the power of 3 minus, here you substitute with 1, you get 1 squared over 2. Okay, so from here you get 8 minus 4 minus 2 is 2, so 8 minus 2, and then here I got 1 minus 1 over 2. Okay, and then after that I further simplify it, I got 5.5 coulomb. Okay, so this is the final answer. Okay, so now we are going to have a look for types of electric current. So basically you have two different types of electric current, which is direct current DC and alternating current, which is we call it as a AC. Okay, so here is example of direct current. Okay, so here is the example of alternating current. Okay, so for direct current is a straight line, which is it means that it remain constant over time. Okay, for alternating current, you get a sinusoidal graph here, so it means that it varies over time. Okay, and then so based on the graph that we have just now, we know that direct current, DC current, is a current that remains constant and does not change with time. So basically, the convention symbol that we use for DC current is a capital letter of I. Okay, for alternating current, is a current that varies sinusoidally with time. Okay, so it changes with time. Alright, so usually we represent the AC current by the symbol of small letter I. Okay, then the conventional current flow. Okay, so why does we need the conventional current flow? Okay, so the convention is actually a standard way of describing something so that other people in the same profession can understand what does we mean. So meaning that we as an engineer, we must define one conventional current flow so that, let's say I know that I have current is equal to 5 ampere, so on this side, so everyone in the world will understand me. So everyone, meaning that in the same profession as an engineer, will understand the flow is actually is from this side to this side. Okay, so let's say if you put the convention current flow is negative 5 ampere. So we know that it's actually the current flow is actually same as per from this side to this side, but if you put the other way around, you must put the symbol of negative 5 ampere. Alright, okay. So once we define that the current is the movement of charge, so we know that the direction of current flow is conventionally taken as the direction of the positive charge movement. Okay, and then a negative current of negative 5 ampere flowing in one direction is actually same as a current of positive 5 ampere flowing in the opposite direction. Okay, so this is the conventional current flow that every engineer should use in order so that other people in the same profession can understand what does we mean. Alright, okay. And then for example, okay, let's say you want to calculate how much charge is represented by 4600 electron. Okay, so how to calculate it? So you know that one electron has a negative 1.602 multiplied with 10 over negative 19 coulomb. So this is the magnitude of one electron. So how many how many charge do we have in the 4600 electrons? So how to calculate it? So 4600 we calculate by one magnitude of the electron. So what we have finally is negative 7.369 multiplied with 10 over negative 16 coulomb. Okay, so this is the total charge that include inside this quantity of electron. So now we go to the next example. Alright, so example 1.3, a conductor has a constant current of 5 ampere. How many electrons pass a fixed point on the conductor in 1 minute? Okay, so we want to calculate how many electrons that going through the conductor in 1 minute. Okay, so you know that 1 ampere is equal to 1 coulomb over second. Okay, so the total number of charges in 1 minute is equal to 5 ampere equal to 5 coulomb over second multiply with 60 second over minutes, because we want to find the value in 1 minute. So in 1 minute you have 60 second, so that's why you multiply 5 with 60, so now you have 300 coulomb over minute. Okay, so and then after that we want to find how many electrons that you have inside of 300 coulomb. Okay, so the total number of electron 300 coulomb over minute is equal to so you know that in 1 coulomb you have 1.602 multiplied with 10 to the power of negative 19 coulomb per electron. So 300 over this number is equal to 1.87 multiplied with 10 to the power of 21 electrons per minute. Okay, so this is the final answer. Okay, so understand? Alright. Okay, so we had done with the concept of current. So now in this slide, we are going to have a look at the concept of voltage. Okay, so in circuit theory, charge separation will create an electrical force. We call it as a voltage, while the charge movement itself create the electrical current. Okay, so if you still remember, when you have a conductor connected to the battery, okay, so it will cause the charge to move, right? So the charge movement create electrical current, and then the charge separation between the positive and the negative electron will the charge separation between the positive charge and the negative charge will create the electrical force called voltage, right? So the energy will build up whenever the positive and negative charges are separated apart. So when the positive and negative try to repel to each other, it will create the energy in between. Okay, so voltage is actually can be defined as the energy per unit charge. So V is equal to W over Q. So W is represented by energy and Q is represented by the charge, right? So how about VAB? Okay, so just now you know the definition for voltage. So let's say you have a voltage VAB. So VAB is represent the voltage between the 2 points A and B in an electrical circuit. So it means that VAB is defined by the energy or the work that needed to move a unit charge from point A to point B. Okay. So by using the mathematical expression, VAB is equal to dW over dQ. So where your W is energy in joules and Q is the charge in coulomb. So VAB, or simply we can call it as a V, is measured in units volt. Okay, so the symbol usually we put in V, right? Then voltage, or we can also call it as a potential difference, is the energy required to move a unit charge through an element. Usually we measure in volts. So usually let's say you have elements, you tap one point here, you tap the other point at point A and point B. So the potential difference, we call it as a VAB. So the polarity of voltage VAB is positive and negative, right? Okay, let's say you have two equivalent circuits. Okay, basically you have this circuit and this circuit. So let's say you have a positive, negative. So here you put it as a positive 9 volt. Okay, let's say you put it as a negative, and here is positive, and then you put here negative 9 volt. It's actually this circuit and this circuit is equivalent. Okay, so the voltage across the element is also 9 volt. Okay, it's not here positive, here is negative, because here you have negative and positive. So that's why the potential voltage across here is equivalent to this side, right? So point A is 9 volt above point B, and from here point B is negative 9 volt above the point A. So this why it's equivalent to each other, right? Okay, so for example of the calculation, okay, if 50 joule of energy are available for every 10 coulomb of charge, what is the voltage? Okay, so by using the definition, okay, so you know that voltage is equal to energy over charge. Okay, so the total of energy over the total of charge. So you know that energy is equal to 50 joule, and then the total of charge is equal to 10 coulomb. So 50 divided by 10 is equal to 5 volt. Okay, so this is the final answer to the question. Alright, so that's all for now. Thank you for your time. Thank you for watching. I'll see you in the next video. Bye.